How many of you have ever taken antibiotics? Modern medicine is dependent upon antibiotics. Whether it's for a child who has an ear infection or an upset stomach or an elderly person with pneumonia, antibiotics are not only important for treating infections, but also for people with reduced immune function, such as patients undergoing therapy for cancer, or HIV/AIDS, transplants, before and after surgery. Antibiotics are critical to the way that we do medicine. So imagine yourself in the year 2050. We're all a little bit older, and with that, our bodies are a little bit older too. What do you think would be the leading cause of death? Well, we expect that it will actually be due to antibiotic-resistant infections. In fact, we expect that in the year 2050, 10 million people will die as a result of these antibiotic-resistant infections. These are the bacteria that stop responding to our antibiotics. My name is Michelle Buckner, and I work on antimicrobial-resistant infections. I try and understand how these bacteria stop responding to antibiotics and what we can do about that. So what are antibiotics? Well, they were first discovered in the 1940s, and over the next 30 years, many new antibiotics were developed. But since then, very few antibiotics have been discovered. And what's frightening is that with that, we've seen an increase in the rise of resistance to every antibiotic we have. And this is where my work fits in. I've discovered a new technique and developed it that uses red and green fluorescent bacteria to watch the movement of these antibiotic-resistant genes. The type of antibiotic resistance that I work on can be thought of a little bit like Pac-Man. They're inside the bacteria, and they're able to chew up and degrade these antibiotics. And one of the neat things about bacteria is they actually form a sort of bridge between even distantly related bacteria. And across this bridge, genetic information, or DNA, is able to move. And that allows new bacteria to become resistant to antibiotics. And this is what I'm doing. I'm trying to stop this process from occurring. Now, the applications of this are very widespread. We could use this in hospitals, in agriculture, in sewage treatment, and even in farming. This work would reduce the amount of antibiotic resistance in the environment and reduce our chances of catching untreatable infections. And with that, I'd like to thank you for your time, and I'd be happy to take any questions.